Well, this is All Electronics Fan, and I'm going to take a look at my Sencore AC Power Right Variable Isolation Transformer and Safety Analyzer. Zoom in a little bit more. There's one thing I actually had forgotten about. The rating on this is 0 to 3 amps continuous, 3 to 4 amps intermittent use. So you get above 3 amps and you got to be careful. Alright, so let's just take a quick look at the buttons on this. The line button tells you what the line voltage is, and it's interesting, it's showing less than, it's showing less than it usually does, yet I'm pretty sure my voltage here has not become less. That may mean this needs to be calibrated. I'm not going to worry about it right now, but 121.3, and this is saying very close to 120, so it's about a volt off. So anyway, so there's that, and then if you hit the output button, that tells you what you selected, what your voltage is based on how you adjusted it. It's got a 0 to 1.5 amp setting that allows you to read that range, and then it's got 0 to 4 amps. Obviously, you can read in that range. It's got a high, so under the leakage section, it's got a high side button and a low side button, and then there's the probe. So let's first take a quick look at our schematic. And this is where I got the information for my probe, and in a minute I'll be showing the video showing how I made my probe, or what's inside it. But the safety probe has a 135 k ohm resistor, 1% they want, and then there's a little switch, a momentary push switch. And the reason this resistor is there is this allows you to check for high levels of AC voltage at 120 up to 120, and this protects your meter from going full scale. It's not going to destroy the meter if this resistor weren't there. It just makes it easier to, well, you'll see when I use the probe. Having that little switch there is helpful. And pressing this switch then actually gives you a reading on your meter, if it's not at full scale already, gives you the actual current reading as seen by the safety probe. So let's just take a couple of seconds to look at the rest of the key part of the circuit diagram. There's your power cord, there's a ground going to chassis, on-off switch. On this, normally on these they have a magnetic breaker in the on-off switch. This one apparently failed and somebody installed just a regular on-off switch. Sadly, they didn't also put a fuse. When I got this transformer, variable transformer, was completely smoked. And it's because they had not put a fuse in here and they had greatly overloaded the unit. When I got it, I put a new fuse on this side of this switch. It's just safer if you are able to turn the power off. If you want to pull the switch fuse and check it, sometimes the fuse doesn't stay in the little black cap that it's supposed to stay in. So if you have this switch on, then you'll definitely know it. You'll get bit. So then this is the isolation transformer, and the isolation transformer feeds this outlet on the front. This is isolated output, and then this side of the transformer is the neutral, and this side of the transformer is the hot side, and then over here is the actual meter, and these two wires feed into this circuit right here, which then provides the input to the meter. So the thing that I want you to see is, well, I'm going to insert the probe video here. I couldn't find a 135K. I'm not sure if they make such a thing, so what I did was, this is the switch assembly that goes inside my homemade probe. It's just plastic conduit. I swiped a little click switch off a circuit board, and there are 3 resistors. In order to give room for this to go against the side there, I put one on top, 2 on the bottom, and I got 134.5K, which is within the 1% tolerance. I don't know how long that switch is going to survive. I'm pretty sure this came out of a low voltage circuit. I don't know what the rating is on it. I'm pretty sure it doesn't tell me. But it works. I have played around with it a little bit. So all I did was stuff this through this little bit of perf board, circuit board material, solder on the wires I wanted to have soldered on, and added my resistors, and that was pretty easy. Used my son-in-law's wood lathe to create the ends, and it's all good to go. Then, now hopefully, the probe I made obviously doesn't look anything like that. They explain how to determine the rating of the unit. Basically, they tell you how to check, how to determine, if you can, what the actual wattage is of the unit that you want to test, or the current. A lot of them don't tell you, unfortunately. Now, some notes about the leakage. Here's another picture of the probe. They tell you that the leakage test must be made with no connections to the chassis except the safety leakage probe. So you don't want the antenna connected, you don't want anything connected, just the basic radio, and of course the power cord. It's going to be plugged into this. So they tell you to do, here's the instructions, which I actually have a kind of have an issue with that. But so they talk about, here I'm on the AC output, and they want you to, let me get this out here, get this ready to go. Alright, so what I need to do is, and I'm hoping that I've got this lined up properly in the camera so I don't have to keep doing this. I guess that's close enough. Alright, so what I want to know is, this is the watts leakage set point, and they say that it should be 117 volts. Let's see if we are. Come on, let's go. Well, are we not making a connection here? Come on. There we go. Alright, so, yes, of course you can do that, because you can. Let's go. Alright, so 117.8, I'll just adjust this slightly. I'm going to call that good enough. Alright. Now, this is where how do I want to put it? I disagree a little bit with their instructions, and you'll see why in a minute. But, so now that I've set this at 117, when they tell you to put the probe here in this side of the outlet, and, oh, I'm sorry. So I've got this set using the output button. I hit the high side button, you'll see, anyway. So I should see 780, and that looks pretty good. I'll call it. I have calibrated this a couple of times, and for whatever reason it doesn't seem to like to stay. Now, here's where these instructions and I part company, because okay, and the front panel. Okay, no, that's not all right. Okay, I got ahead of myself. Okay, maybe, just maybe, I made a mistake, but give me a second here. Alright, these are the instructions on how you test. Okay, they are telling you to do that. Plug the unit to be tested in isolation, turn it on. Okay, now, this part about the 117 volts, to me this is simply about the calibration. But the calibration, once you've done it, should be pretty much okay. And here's why I disagree. So they talk about touch to probe every piece of exposed metal, including screw heads, antennas, antenna terminals, etc. And then they tell you to press the low side leakage and so on. Low side leakage push button and repeat the test. We will do that. Okay. Now here's where I have an issue with what their instructions. This, you saw me test that this was going to 780 milliwatts, or milliamps, I'm sorry. And they call it here microamps, I think. But anyway, see what they're saying? 800 milliamps. The only way you can get 800 milliamps, get an 808 milliamp reading, is if you, I'll do this, and you bring it up to 120. Alright, my light is making a shadow, so I can't see. Go away. I guess it's alright. Okay, no matter. Alright, so I've got this at 120. Now watch, I push this in to the test point. Now darn, high side, now we go there. And guess what? That is your 800 milliamps. The only way you're going to get 800 milliamps is if this is set at 120 volts or higher. But since this stops at 800, setting this to 120, that's probably as high as you want to go. So this is where I disagree. They don't tell you to go back here to your output, set it to 120, and then go to the high side and check. They don't tell you to do that. But there's no way in the world you're going to get 800 milliamps, get an 800 milliamp reading, if this is not set to 120. Not going to happen. So these instructions seem to be a bit lacking. But let's continue. Alright, so they talk about maximum allowable leakage being printed on the manufacturer's service literature. Maybe I haven't seen it because I've been looking for it, but I don't. Well, sometimes all I have is a schematic, and that doesn't always give you everything. But even on the devices that have full documentation, I don't recall seeing this. I will definitely be looking for it in the future, but I don't remember seeing it. So they're saying the present level of leakage on consumer electronics is 500 microamps, or milliamps if you prefer. Some will publish a figure lower than that. And then here's what's interesting is prior to 72, the devices were designed to meet 750 microamp leakage level. Now this is true as of when this was printed, and I don't know when that is. One of the things you'll find out in documentation is that quite often they don't put a date on it to tell you when it was printed. But I don't know if this changed later on, if any of this changed, but that at the writing of this is what they're suggesting. And then they talk about testing it on 3-wire devices. Okay. Yeah, I don't quite understand why the instructions are what they are. So, I need to show you. Okay, so I actually didn't get this at first, so I'm pretty sure I'm not alone. I'll get this out of the way for a minute. So, when you press the high side, here's what you see. Or here's what you get. Meter, meter. Alright? And this is really basic. If you look at the actual schematic, you'll find there's a lot more going on. So when you push the high side button, the meter is connected to the neutral side of this transformer. And then that means that the probe is essentially looking through this meter to the neutral side. So if I grab the probe, like I just did, and plug it and touch it into this side, I'm going to get a reading on the meter, and if this is at 120 volts, I'm going to get the 800 milliamps reading. And then if you push the low side button, now the meter and probe are connected to the hot side of the transformer. And if I were to touch my probe here now, I would get no reading because basically it's a dead short, so there's no current, no voltage. And if I were to touch my probe over here, same thing, I would get no reading on my meter because it's a dead short. So let's go down here to my hypothetical radio. Now, this sensibility is the chassis of the radio, and this is just the connection to the electronics inside the radio. Same thing here. This is chassis, and this is inside. And these pins are lining up with this hot side neutral. So a properly wired radio, the chassis will be connected to the neutral side of the outlet, and then of course the other side goes to the hot. Now if your radio is wired correctly or it doesn't have a polarized plug on it, you can plug it in another way, and then if you do this, now you've got your chassis connected to the hot side. So if I take my probe, I've got this side set up, and I've got my radio plugged in so that the chassis is hot. So it's here that the chassis is connected. So I take my probe and I touch the chassis. Well, I'm touching this basically because the chassis is connected to this, and then I will get the 100 milliamp reading, unless there's something else going on between the chassis and this connection. In some cases there is a capacitor between this leg of the power lead. So now this capacitor is doing things to try to reduce the current. So if you have the appropriate size capacitor between the chassis and here, your meter reading is going to be lower. So I hope that makes sense. I hope I'm clear enough. This is your AC, and this is the isolation transformer in this. Alright, so I've got a radio here, and at first I didn't think I was going to be able to use it because I thought, because I have a polarized plug on this. But I'm going to cheat and I'm going to use this. But I'm going to start off with plugging this in the correct way around. And alright, I'm going to back out a little bit so you can see more of what's going on. So I'll put this in here. Okay, so I'm on low side. Just have to turn this on. This is set to 120. Sure it is. Yes, it is. So then now we're going to go here. So as I mentioned before, because this is a properly wired radio, when I go to this radio, I get nothing. Now, that's to the chassis. But let's check. I forgot to do this when I was playing around with this. These are the antenna connections. So let's see how we make out here. Nothing. And I go here, nothing. Headphone jacks, nothing. Alright, so that's the way you want it to be. Now, let's take this and put that in there. But now I'm going to take my neutral, what was my neutral side, I'm going to flip this over, I'm going to plug this in here, and now, and this should be pretty close to warm already, and it is. Alright, so let's check this out. Yeah, we're pegging the meter. That's 800, and I go over this little piece of, there are some switches mounted on here, and this is what actually is screwed to the metal case, and there's an isolation, there's an insulator here that keeps this from being directly connected to this, and but if I touch this, I still get full voltage, and we'll go over that shortly. So now let's check this. Alright, so I've got my antenna. It's saying that I'm at 400. So this is where my switch comes in. So it's at 400 milliamps. If I touch this, that is good because this is still below 500. And that's the point of this. I check this, it pegs the meter. I know I don't need to bother with this switch because it's already at maximum deflection. But I go here, it's not at maximum. I depress it, and that tells me my actual current is around 460. I go here, and do the same thing, and it's about the same. So that's how you use this. Now, they talk about going to the low side and testing again. Well, let's take a look at this side, at this again. Low side, now this is connected to the hot side of the transformer. So now when I go and I check things out, I'll stop, I keep hitting that. Nothing. And it's pretty clear why that is, because, let's go back here. The chassis, I've gone to the low side, but the chassis, when this is plugged in the way it is, hot side, this goes to the chassis. So now when I touch my probe to the chassis, since it's already connected to this side, it's a dead short. And so therefore, I get no response. If I go here, nothing, nothing. Now, where do I want to hit from here? Alright, so one of the things I wanted to do, let me just get this out of here for a minute. Yes, let's put this here. Actually, I'm going to put it in the wrong way again. Yes, alright, we're going to do this. Now, one of the things I wanted to do And this was before I actually had figured out this part. I just wanted to see if, yes, I know. I just wanted to see if I could read voltage from here to here. I get 59 volts. So, oh, what did I do with my old cord? What did I do with that? I'm really good at misplacing things. Okay, back to where I was going. So what I wanted to do was I wanted to, again, this is when I was playing with this early on, and I just really wanted to check to see what the actual voltage was on here. And when I saw that I was getting this voltage, I was very puzzled. So it turned out it was a good thing, though, because I discovered something important. This is broken. I did not realize it. It doesn't really show that, it doesn't really, and there's nothing that really says that it's broken just by looking at it. But in the course of checking this out, I actually checked to see if this ground pin was actually grounding, and I could get up to 150 ohms just by wiggling this. So this is clearly no good. This now has a brand new cord on it, and so that makes me feel a lot happier. So some of the things I learned in the course of going through all this is, number one, because of how this is made, get this out of the way, turn it off because it's blinding me. Alright, so let's take another look at our schematic here. So variable transformer, isolation transformer, that feeds these two pins. The power cord going to the Sencore goes to chassis ground. This connection goes to chassis ground. So there's absolutely no way you can get a real voltage reading from here to here. Because this, and trust me, I went through, I don't even want to see how much time I spent trying to sort this all out. When I saw that voltage on here, I thought there was something wrong, that there was leakage coming from somewhere, or that there was some ground connection on this board that I didn't see when I was looking at the schematic. I actually had this board out of the Sencore, sitting next to it, and I was still getting 10 volts on this. And in fact, if I moved, and the way I did it, I used, I disconnected everything from the board. All these connections were removed. So the board is just sitting next to the Sencore chassis. And I took a cord that had bare ends, and I connected the AC to this one and this one. You'll have to bear with me. I got confused. So I knew that there was no way in the world I was going to make it clear what I was actually doing. Alright, so as I recall, my goal was to isolate this board completely from the chassis. So I started out, I was just going to isolate the transformer and all of that, but then I ultimately decided to just go all the way and just take the board out. So these two connections here, this is the AC coming from the transformer, so I connected that piece of wire, that power cord with the bare ends, one here and one here. I connected a wire to the ground that this wire was soldered to inside the case. Then I also connected a jumper wire to pin 10, which is the positive side of, or the hot side of the outlet. And so the reason I did that was oh yeah, okay. So what I was trying to do was I wanted the board. I moved the board outside of the case, and I only had 3 wires connected to this circuit board. This one, and this one. And so what I did was I checked between the green inside the case to the hot wire, which if you follow this over, I could have checked, I could have connected it here. Well, it's got a small resistance there, but anyway, I wasn't thinking. I didn't really need to put a jumper on there, but I did, and I used that to test between here and here to see if I had voltage. That's what I did. When I started out with the board right next to the case, I had around 12 volts between here and here. So on a whim, I decided to separate the two, because I was really thinking that there was something inducing a voltage. I didn't know what, but what the heck. So as I separated this from the board I had sitting on my bench, I actually got the voltage down to around 9 volts between here and here. Which was extremely baffling, although it definitely led credence to the fact that there was a voltage being induced from somewhere, but from where? The transformer was not powered up. The transformer, while the frame of the transformer was indeed connected to ground, there was nothing. There was nothing. Let me think. Yeah. So the transformer was not connected here. I had a separate AC line feeding here. The frame of the capacitor was grounded, but that's it. I mean, anyway. So that's what I actually did. 2 wires here, 1 wire here, compared voltages, and just really left baffled. While I had the board out, I checked it over thoroughly. I cleaned it to make sure there was looked like there's some oil and dust that had built up on part of it, so I cleaned that off, because I know how, if you get conductive material in the dust and oil, that can it can cause it to have an actual connection. If the voltage is high enough, it will start burning your circuit board as it arcs. But I couldn't find anything wrong with it. I checked everything relative to ground while it was in there. I came up with no good answers. I was just totally shocked. So I was basically just I basically said, well, I'm just going to put it back together, which is why it's back together. I don't know what's going on, but there's something strange going on here. Well, as it turns out, on this meter, my new meter, it's got a feature that I've never seen before. And I think one of the reasons why, this came from my local hardware store, I think one of the reasons why this feature is on here is because this was, I guess, kind of aimed at people who deal with, who are electricians, who are dealing with AC powered appliances and that sort of thing. But this is what helped me find out for sure what is going on. It's called low Z. Now, when your meter is set at any one of these other connections, the impedance, the resistance in that meter, and I looked on the meter itself and it doesn't tell me that, but I believe it's 10 megohms of impedance here. And so with that much impedance, when you put your meter across a circuit, it's not going to draw the voltage down very much. It's going to be a teeny tiny amount. That means that if you have high resistance connection, say 500 ohms, so you're trying to test a dryer, you test the you test at the outlet and you get 240 volts. You test at the appliance and you got 240 volts using this setting. You may have a high resistance in one of the wires and you'll never find it using this, because this doesn't really draw any current to speak of. However, if you do this, now it's going to make a difference. So let's go back to this, and I'm going to, in fact, what do I want to do here? All right. So if I go here and here, hang on, 60 volts. Now on low Z. What do you see? 0.06. This is called a ghost voltage. In fact, you see it, go back here for a minute. So if I measure from here to here, I have 30 volts. I go over to here, 66 volts. But if I go to low Z, 0.03, 0.03. That 30 volts and that 60 volts is a ghost voltage. I tried to figure out where the ghost voltage was coming from in this. Like I said, I had the board for this Sencore out of it. And other than reducing the voltage, I never was able to pin down why. And I even experimented. I took that power cord that I had used to supply power to the circuit board, and laid it down alongside a regular cord and tried to see if there was voltage being induced from one to the other. And of course, that wasn't the case. So I just was totally shocked that much voltage was really not real voltage. It was what they call ghost voltage. So something about the design of this, and like I said, originally thought it was the transformer, but I actually unbolted the transformer from the case and I insulated it from the case using paper. When I did that, and this was with the board still in there and with the transformer still being powered by the power cord from this, I was getting 25 volts on the frame of the transformer and I think 30 volts here on my ground. So I said, surely there's something squirrely with the transformer, which is when I went to, well, let's just get rid of everything. And I did. I got everything disconnected. Fed power in here, the red and red-white, and still I had voltage on this ground. Obviously, with the circuit board outside of the case, I got a lot lower voltage. Like I said, I think it ranged between 12 and 9 volts depending on how far away it was from the case. So that's kind of bizarre. But now I know what it is. I know it's not harmful. Because that was one of the other concerns I had was, is this thing really safe? So once I found out what it was, I was able to touch this and touch a ground. I have a ground up on my little, this actually goes straight to ground on the 3-prong outlet. The ground cord, the ground pin on the power cord to this is actually grounded to this. So I could touch this and this, and there wasn't even a slight tingle. This ghost voltage doesn't have any current really. So that definitely kept me going. Oh, there's one other thing though I did want to do. Yes, I almost forgot. So let's go back to, we're going to put this in the wrong way around. That should be there. And that should mean that I have, we're there. Yep, there we are. Now, this is where I wanted to go to, because this kind of is what started all of this stuff happening. Alright, so I've got this here. Now there's a 0.15 microfarad capacitor that goes from here to here. And as you can see, it's still full scale. Well, that had my head in the spin. So let me show you. I put a 0.15 in here. I think that's what I had at the time, and it was not what was called for in the schematic. They wanted you to put in a 0.1. Okay, so this is also a 0.15. There's a reason I'm grabbing that one out. Now I want to look at, now I want to get, alright, a 0.015, there it is, okay. So, you'll find this rather interesting. I think, anyway, find out. Alright, so I'm going to plug this in, and I hate them when they don't cooperate. They want to, I know I've got one that's not going to misbehave. It spins my fingers when I try to clamp it. Alright, there we go. Those are newer ones. Alright, so I'm clamping this to the chassis because I want to mimic this. Because this this capacitor is simply there to reduce, I believe it's designed to keep noise under control. I think they're trying to keep RF noise at bay, and because this winds up bolting or screwing to the case, which is all metal, and that makes a very fine antenna. So they're trying to, and so does this. That's also a very nice antenna. So by connecting this to this with a capacitor, they're trying to reduce noise and make it work properly. But let's see. Oh, do I have a 0.1? I think that's 0.1. Should be 0.1. Yes. No, that's 1. 0.1 would be 4. Oh yeah, that's right. Never mind. All right, so here I've got a 0.1. So this is the capacitor that they call for in this. All right. And remember, I've got this plugged in the wrong way around, so the chassis is hot. Full scale. Really. Alright, so we'll take 0.1 and take that away. Now, so I thought, well, a 0.015, will that work? Now that looks better, doesn't it? You can zoom in a little bit. Let's throw some more light on it. So 0.015, he's blinding me. Alright. Okay, so that's over 500. So now I push my button to tell me what the actual current is. Now it's close to 700, it's like 680. So a 0.15 doesn't work that well. And so I thought, well, is it just that type of capacitor? Here's another point, yeah, 0.015. Same thing. So I thought, well, that's interesting. So let's try a 0.01. Here we go. And now it's at 400 and it's just under 500. So with a 0.01 capacitor in this, so if I replace this capacitor that goes from here to here, that reduces the current down to, it's about 480. And so what I think I'm going to do is I'm going to test this radio with the capacitor that's in it. Then I'm going to put this one in and test to see how this one behaves. If I don't see a difference in terms of noise and performance, this is going to stay in here. And you might be wondering, well, why would you do that? Well, it would seem strange in this day and age that to say that not all houses and all outlets are these. Not that long ago I was in a house where they had just two-prong outlets. There was no ground. So guess what happens? If you have a three-prong, well, if you have a polarized plug, it's not, a lot of those two-prong outlets don't have the larger slot. This won't go in. So they do this. So now they have a 50-50 chance of this thing being hot. So my thought is, by the way, this chassis, the way it was designed, the one leg of the AC was connected directly to the chassis. Now they've done things like, they did do things to try to make it safer. If you look at the front, this is circuit board material which isolates these from the chassis, which is a good thing since these are these have Allen wrenches securing Allen screws that secure this knob to this radio. And if, say, the Allen screw loosened up and you say, oh, I want to fix that, and you grab your Allen wrench and you start tweaking on that, but this was grounded, this was actually connected to the chassis, and your plug was plugged such that the chassis was full 120, yeah, you would know that. That would not be good. They did do some safety stuff. I'm kind of surprised. I'm assuming that Sencore knows what they're doing when they're talking about what the ratings are and what this will do and why, how useful this is. So this has been really interesting. I've spent oodles of time on this, and it's been interesting, and this is now safer because I found out that I had a bad ground on my power cord. Not ideal. I'm really careful regardless of what I'm working on. Even though I've got it hooked up to this, I still try to be very careful about what I'm doing with this and how I'm not allowing myself to get grounded, just because. Although, after playing with this and learning more about it, especially playing around with the ghost voltage part, I think I'm much more comfortable using this than I was before. Still doesn't mean I'm not going to be very careful, but now I've learned a whole lot more about this, and I really do think that this is safe. That was one of my questions: is this thing safe? And I think the answer for me now is yes. So I'm wrapping up here. Hope this was interesting to you. This has been a huge investment in time for me. But I think given that I learned a whole bunch of stuff along the way, it was worth doing. And now hopefully you guys will learn something as well. And certainly look forward to comments on this, and if somebody has more knowledge than I have, I'm happy to receive it. So leave your comments, leave a like if you feel like it, and subscribe. I'd really love to have you. Thanks.